When we look at the night sky, it seems that we see everything stars, planets, the Milky Way. But in reality, we are only observing a tiny part of the universe. Most of the cosmos remains completely invisible to our eyes and even to the most powerful telescopes. And today we will immerse ourselves in an exciting journey through the world of hidden space objects that change our understanding of reality. Let's start with the most mysterious, dark matter. Imagine. Scientists claim that approximately 85% of all matter in the universe is completely invisible. This is not fiction. This is a scientific reality. Dark matter does not emit light, absorb it, or reflect it. It is completely transparent to all forms of electromagnetic radiation. Then how do we even know about its existence? It all started in the 30s of the last century, when Swiss astronomer Fritz Zwicky studied galaxy clusters in the constellation Hare Veronica. He noticed something strange. Galaxies were moving much faster than they should, given the amount of visible matter. According to the laws of physics, they should have scattered in different directions, but this did not happen. Something invisible held them together with its gravity. Astronomers later discovered even more impressive evidence. When they observed the rotation of galaxies, it turned out that stars at the edges of galaxies move at the same speed as those closer to the center. This contradicted all calculations. The only explanation is that there is a huge halo of invisible matter around the visible part of the galaxy, which affects the movement of stars. Today, scientists hunt for dark matter particles in deep underground laboratories protected from cosmic rays. They created ultra-sensitive detectors cooled to almost absolute zero, hoping to record at least one instance of a dark matter particle interacting with the detector's atoms. But for now, she remains elusive, like a ghost passing through walls. Now, let's talk about something even stranger, dark energy. If dark matter at least behaves like matter, creating gravitational attraction, then dark energy does the exact opposite. It pushes the universe apart. In the 98th year of the last century, two independent groups of astronomers studied distant supernovae, explosions of stars that can be used as cosmic milestones to measure distances. And what they found stunned the scientific community. It turned out that the universe is not just expanding, it is expanding with acceleration. It's like throwing a ball up and seeing that instead of slowing down and falling backwards, it flies faster and faster. Something pushes all of space, causing galaxies to move away from each other at ever greater speeds. It's something called dark energy, and it makes up about 68% of everything in the universe. What is? No one knows. Maybe this is a property of space itself, some kind of internal vacuum energy. Maybe it's a whole new field that permeates the entire universe. Or maybe our understanding of gravity on cosmic scales is simply wrong. But one thing is clear, dark energy determines the fate of the universe. If it continues to accelerate space, in billions of years, galaxies will be so far away that no stars other than those in our own galaxy will be visible from Earth. But it is not only these mysterious substances that are hidden. In space, there are objects so extreme that they literally hide from our view. I'm talking about black holes. These are not just dark spots in space. These are places where space and time are distorted to such an extent that even light cannot escape out. A black hole forms when a massive star exhausts its fuel and collapses under its own weight. Imagine that you compress an object the size of the sun to the size of a city, and then continue to compress to the size of your little finger, and so on, until all that mass is concentrated at a point of infinitesimal size. This is a black hole, a singularity surrounded by an event horizon, a boundary beyond which nothing can return. How can we detect something that is by definition invisible? By impact on the environment. When gas and stars get too close to the black hole, they begin to orbit it, forming an accretion disk. The matter in this disk accelerates to enormous speeds and heats up to millions of degrees, emitting powerful X-rays before disappearing forever beyond the event horizon. At the center of our own galaxy, the Milky Way, lurks a supermassive black hole called Sagittarius A-. Its mass is 4 million solar masses, compressed into a volume smaller than the orbit of Mercury. For decades, astronomers have observed stars orbiting something invisible in the center of the galaxy. And this is what made it possible not only to prove the existence of a black hole, but also to measure its mass with incredible accuracy. And in the year 2019, a real revolution took place. For the first time in history, mankind saw the shadow of a black hole. Using a network of radio telescopes located around the planet, scientists combined them into an Earth-sized virtual telescope and photographed the black hole at the center of the distant galaxy M87. The picture shows a ring of light. These are photons that orbit the black hole at the edge of the event horizon, and a dark shadow in the center, the black hole itself. But black holes aren't just space vacuum cleaners. They can be the sources of the most powerful phenomena in the universe. When two black holes merge, they create ripples in the very fabric of space-time, gravitational waves. These waves propagate through space at the speed of light, and when they reach Earth, they cause microscopic fluctuations in space. So microscopic that detectors several kilometers long were needed to detect them, capable of measuring changes smaller than the diameter of a proton. The first direct detection of gravitational waves in the year 2015 opened up a whole new way of observing the universe. We can now hear events that were previously completely hidden. Black hole mergers, neutron-star collisions, perhaps even echoes of the Big Bang itself. Speaking of hidden objects, one cannot fail to mention neutron stars, these cosmic wonders that almost turned into black holes. When a massive star explodes as a supernova, sometimes its core does not collapse completely into a black hole, but stops at an intermediate stage. Protons and electrons are compressed together to form neutrons, and the result is an object the size of a city, but with a mass greater than that of the Sun. The density of a neutron star is so incredible that 1 teaspoon of its matter would weigh more than 1 billion tons. Imagine this figure, 1 billion tons in a teaspoon. If you could somehow transfer a piece of a neutron star to Earth, it would instantly fall through the planet like a knife through butter. Some neutron stars rotate at incredible speeds, hundreds of times per second. These are pulsars, cosmic beacons that emit powerful beams of radio waves from their magnetic poles. When these rays are directed at the Earth as the star rotates, we see regular pulses like the flashing of a distant cosmic beacon. The first pulsar discovered was so regular that astronomers initially thought it was a signal from an alien civilization. And magnetars are an even more extreme type of neutron star. They have the strongest magnetic fields in the universe, quadrillion times more powerful than the Earth's magnetic field. If a magnetar were halfway to the moon, its magnetic field would tear apart the molecules in your body. Sometimes magnetars produce flares, explosions of energy so powerful that they can affect the Earth's magnetosphere from a distance of thousands of light years. Now let's talk about objects that lurk, not because they don't emit light, but because they're too far away or too dim. Brown dwarfs are so-called failed stars, objects that formed like stars from clouds of gas and dust, but did not gain enough mass to ignite thermonuclear fusion in their interior. They hovered somewhere in the middle between giant planets and real stars. Brown dwarfs are so dim that they are extremely difficult to find. They emit mainly in the infrared range, so special telescopes are needed to detect them. And here's what's interesting. Scientists suggest that there may be billions of brown dwarfs in our galaxy, perhaps even more than real stars. They just hide in the dark, invisible and unnoticed. Another category of hidden objects is orphan planets, worlds that have been ejected from their star systems and are now roaming interstellar space in complete darkness and cold. Imagine an Earth-sized planet or larger traveling through a galaxy without a star, without a sun in the sky, in eternal night. How many such worlds are there? Some estimates suggest that there may be more orphan planets than stars in the galaxy. It is almost impossible to detect such objects because they do not reflect starlight and emit almost no heat of their own. Sometimes they can be caught thanks to the microlensing effect. When an orphan planet passes between us and a distant star, its gravity momentarily focuses the star's light, causing a brief flash of brightness. But these events are so rare and short-lived that millions of stars need to be constantly observed at the same time to detect them. And what do you say about objects that are hidden simply because they are in places where we cannot look? For example, the avoidance zone is a region of the sky enclosed by the disk of our own galaxy. As we look toward the center of the Milky Way, thick clouds of dust and gas block our view. Anything can hide behind this curtain. Galaxy clusters, supermassive black holes, entire galaxies that we do not even know about. Scientists are using X-ray and radio telescopes to penetrate this veil, and they have already discovered several hidden galaxies that were previously invisible in the optical range. One of the most famous is the Sagittarius dwarf galaxy, which is actually merging with our Milky Way right now, but went unnoticed until the end of the last century because it was hidden behind stellar clouds. There are also objects that are hidden in time. Quasars are extremely bright nuclei of distant galaxies powered by supermassive black holes that actively absorb matter. They are so bright that they can outweigh the luminosity of an entire galaxy. But all the quasars we observe are at enormous distances, which means we see them as they were billions of years ago. The light from these objects traveled through space for billions of years before reaching our telescopes. We are literally looking into the past, observing the universe as it was when it was younger, more turbulent and chaotic. The farthest quasars we see existed when the universe was less than 1 billion years old. They show us an era when galaxies were just forming, when the first supermassive black holes grew, absorbing huge amounts of matter. But here's the surprising thing. In the modern universe, around us, quasars have practically disappeared. Most supermassive black holes at the centers of nearby galaxies are now quiescent, inactive. They have exhausted their fuel or simply went into hibernation mode. This means that an entire era of cosmic history is hidden from us simply because we live in a different era. We can't see active quasars nearby because they are no longer there. They are hidden in the past. And this brings us to an even deeper mystery: the dark ages of the universe. After the Big Bang, when the universe cooled down enough for the first atoms to form, there was a long era of darkness. There was no light. Stars have not yet been born. Galaxies have not yet formed. The universe was filled with neutral hydrogen, which absorbed almost all of the radiation. This dark age lasted hundreds of millions of years. Scientists call it the cosmic Middle Ages, and we know almost nothing about what was happening at that time because there is no light that has reached us from that era. This is literally a hidden period in the history of the universe. Only now, thanks to the James Webb Telescope, which can see in the infrared, are we beginning to break through this veil and observe the first galaxies that were born at the end of the Dark Age. But even James Webb can't see everything. There is an absolute limit to our observation, the cosmic event horizon. This is not a physical object, but a boundary beyond which we fundamentally cannot look. The universe has a finite age, approximately 13,800,000,000 years. This means that the light has only had so long to reach us. Everything that is further than a certain distance has simply not yet had time to send us its light. Moreover, due to the expansion of the universe, there are galaxies whose light will never reach us. The space between us and them is expanding faster than the speed of light. Yes, space can do that. Limiting the speed of light is about moving through space, not expanding space itself. These galaxies are forever hidden from us, not because of physical obstacles, but because of the very structure of space and time. Now imagine this. Perhaps there are entire universes hidden from us. String theory and some other theoretical models suggest that our universe may be just one of countless universes in the multiverse. Each universe can have its own laws of physics, its own constants, its own history. Some may be similar to ours. Others may be completely alien, with a different number of dimensions of space, with different fundamental forces. If this is true, then these universes are forever hidden from us. We cannot travel to them. We cannot observe them. We cannot even prove or disprove their existence by direct observations. They exist in some abstract space of possibilities, separated from our reality by a barrier that cannot be overcome. But back to the objects that can be observed, at least theoretically. Primordial black holes are hypothetical objects that could have formed in the first moments after the Big Bang, when dense regions of space collapsed under their own weight. Unlike ordinary black holes, which form from massive stars, primordial black holes can have any mass, from microscopic to huge. Some scientists suggest that it is primordial black holes that may be the very dark matter we are looking for. If there are billions of small black holes scattered in the universe that are the size of an atom, or even smaller, they would be invisible but would create the necessary gravity. However, it is extremely difficult to detect such objects. They are so small and numerous that it is almost impossible to observe them individually. There is also a phenomenon called gravitational lensing, which allows us to see hidden objects indirectly. When a massive object, such as a galaxy cluster, is between us and a distant light source, its gravity warps space, acting like a giant lens. Light from distant galaxies bends around the cluster, creating distorted, stretched images, and sometimes even multiple copies of the same galaxy. It's not just an interesting visual effect. Gravitational lensing allows astronomers to see galaxies that would otherwise be too dim and distant to observe. The cluster lens acts as a natural telescope, amplifying light from the oldest and farthest objects in the universe. Thanks to this effect, we were able to see galaxies that existed less than 1 billion years after the Big Bang. But gravitational lensing also reveals something else: the distribution of dark matter. Since dark matter has mass, it also distorts light. Astronomers can map where dark matter is in galaxy clusters by observing exactly how images of background galaxies are distorted. And what they find confirms that there is much more dark matter than ordinary matter. It forms huge cosmic webs that permeate the entire universe, structures so large that individual galaxies seem to be just nodules on them. Speaking of large-scale structures, it is worth mentioning cosmic voids, huge regions of space where there are practically no galaxies. These voids can reach hundreds of millions of light years in diameter. There is so little matter inside them that they look like space deserts. But they're not completely empty. Even there's dark matter and dark energy, and there may be individual orphan planets or dim dwarfs wandering around. The largest known cosmic void, the Eridanus void, is so large that it takes light 1 billion years to cross it. Inside this void, researchers discovered another anomaly, a cold spot in the cosmic microwave background radiation, an echo of the Big Bang. Some scientists suggest that this cold spot could be a trace of our universe colliding with another universe in antiquity. But this remains a highly speculative hypothesis. Another type of hidden object is the interstellar objects that visit our solar system. In the year 2017, astronomers discovered a strange object flying through our system at incredible speed. He was named Oumuamua, which means scout or messenger in Hawaiian. It was the first confirmed interstellar object. It came from outside the solar system and is now leaving it forever. But Oumuamua was strange in many ways. Firstly, its shape is oblong, like a cigar or a pancake, which is unusual for asteroids. Second, it accelerated as it flew away from the sun, as if it were being pushed by some additional force. This may be caused by the evaporation of volatiles like comets, but Oumuamua did not have a visible tail. Some scientists have even suggested that it could have been an artificial object, a space probe from another civilization, although most astronomers are inclined to a natural explanation. How many of these interstellar wanderers fly through the solar system unnoticed? We only discovered Oumuamua because it passed close enough and was large enough. But there may be thousands of smaller objects constantly traveling between stars, invisible and unnoticed. Perhaps some of them contain organic molecules or even microscopic life, carrying biological material from one star system to another. This brings us to one of the biggest mysteries. Is there another life out there in the hidden depths of space? Exoplanets, planets orbiting other stars, are now discovered by the thousands. We know that planets are common in the universe. Some of them are located in the so-called residential area, where the temperature allows the existence of liquid water on the surface. Or are there life on these planets? This remains a hidden secret. We cannot yet directly observe the surface of exoplanets. They are too small and dim compared to their stars. It's like trying to see a firefly next to a spotlight thousands of kilometers away. However, astronomers have developed ingenious methods. When a planet passes in front of its star, it blocks a tiny fraction of the light. By analyzing how the spectrum of this light changes as it passes through the planet's atmosphere, scientists can determine the chemical composition of the atmosphere. And that's where things get exciting. Certain combinations of gases in the atmosphere can be biosignatures, signs of life. For example, oxygen in large quantities is chemically unstable and quickly disappears if something does not constantly produce it. On Earth, plants, and other photosynthetic organisms do this. If we were to detect a planet with a lot of oxygen and methane at the same time, it would be a powerful clue in favor of life. The James Webb Telescope has already begun to study the atmospheres of exoplanets in unprecedented detail. Perhaps in the coming years or decades, we will discover the first true signs of extraterrestrial life hidden in spectral lines of light from a distant world. Or maybe life exists in forms so different from earthly that we don't even know what to look for. Some scientists suggest that life may exist not only on planets. Moons of giant planets, such as Europa, a moon of Jupiter, or Enceladus, a moon of Saturn, have subsurface oceans of liquid water beneath a thick, icy crust. Geysers on Enceladus eject water into space, and spacecraft have already flown through these emissions, analyzing their composition. There are organic molecules, salts, signs of hydrothermal activity. All the ingredients for life are present. Could something living in the dark depths float beneath the icy surface of Enceladus, feeding on chemical energy from hydrothermal vents, similar to ecosystems at the bottom of Earth's oceans? This possibility is so mesmerizing that future missions are already planned to search for signs of life in these hidden oceans. But the most unusual form of hidden life may be life inside the stars or planets themselves. It sounds absurd, but some theorists suggest the existence of life forms based on completely different principles. Not chemical reactions, but, for example, magnetic fields or nuclear processes. In the plasma of a star or in the extreme conditions of the planet's core, complex, self-organized structures can arise that reveal the properties of life: metabolism, reproduction, evolution. This is pure speculation, of course, but it shows how little we really know about the possibilities of the universe. Life can hide in places that we don't even consider as potentially habitable. Maybe it's all around us, but we just don't recognize it because it's so different from what we know. And this brings us to another group of hidden objects: artificial ones. If there are highly advanced civilizations in the universe, where are their traces? This question is known as the Fermi paradox. The Milky Way contains hundreds of billions of stars, many of which are billions of years old. Even if only a tiny fraction of them have planets with life, and an even smaller fraction develop technological civilizations, there should be many of them. But where is everyone? One possibility is that highly developed civilizations hide themselves on purpose. Perhaps there are good reasons to go unnoticed. Space predators that destroy any civilization that betrays its presence. In this case, the cosmos can be filled with hidden civilizations, each of which is silent and listening, trying to discover others without revealing themselves. Another possibility is that highly advanced civilizations use technologies that we simply cannot detect. Maybe they're communicating through gravitational waves or some other channel that we don't even know about. Or they are so efficient in using energy that they leave practically no noticeable traces. A civilization that makes full use of its star's energy through a structure known as a Dyson sphere would absorb all visible light, but emit in the infrared. Astronomers are looking for such anomalous stars, but have not yet found convincing candidates. And perhaps the most disturbing answer to Fermi's paradox is that we ourselves are among the first. Perhaps the universe was too young and chaotic for life to emerge for most of its history. The first generations of stars did not have the heavy elements needed to form terrestrial-type planets. Perhaps only now, after billions of years of evolution of the universe, have conditions become favorable for the development of complex life. And if this is the case, then the space around us may indeed be empty, hidden not because of the conscious efforts of other civilizations, but simply because they do not exist yet. But there's another hypothesis that makes you think. What if intelligent life inevitably destroys itself? Perhaps there is a certain technological barrier. The moment when a civilization acquires the ability to self-destruct but does not yet have the wisdom to avoid it. Nuclear weapons, artificial intelligence that is out of control, ecological collapse, pandemics created in laboratories. There are many ways in which a technological civilization can destroy itself before becoming interstellar. If this is the case, then space may be a graveyard of civilizations, each of which flashed for a brief moment and faded, leaving behind only silent ruins on distant planets. These archaeological sites of alien cultures are hidden from us by vast distances, and we may never find them until we develop the ability to interstellar travel. Speaking of interstellar travel, it is worth mentioning cosmic jets and space freeways. Scientists have found that gravitational interactions between celestial bodies create special trajectories in space, paths where the spacecraft can move with minimal fuel consumption, using only gravity. These trajectories form a complex network of space highways that permeate the solar system. But what is interesting is that such structures can exist at the galactic level. Dark matter forms filaments and knots in the cosmic web, and these structures create gravitational channels. A highly advanced civilization could use these natural highways to move between the stars, saving huge amounts of energy. Perhaps right now, as we speak, someone's spacecraft are racing along these hidden routes, invisible to our telescopes. Now, let's talk about temporal anomalies. Einstein's general theory of relativity predicts that a strong gravitational field slows down time. Near a black hole, time passes much more slowly than far away from it. If you could survive near the event horizon of a supermassive black hole, an hour could pass for you, while millennia would pass in the rest of the universe. This means that there are objects hidden in the future. Imagine a civilization that decides to build its city in orbit around a black hole, at a point where time is slowed down thousands of times. Days and months would pass for them, while the surrounding universe would age by millions of years. They could travel into the future just waiting in their orbit. When they finally decided to return to the galaxy, they would discover a completely different world millions of years in the future. The theory of relativity also predicts the existence of closed time-like curves, trajectories in space-time that loop on themselves. Theoretically, if such structures existed, they would allow travel to the past. But do they really exist? Most physicists are skeptical of this idea, as time travel generates paradoxes that seem unsolvable. But mathematically, this is possible under certain extreme conditions. Inside rotating black holes, or in the presence of exotic matter with a negative mass. If closed time-like curves exist, it opens up amazing possibilities. Perhaps there are events or objects in our past that actually came from the future, or vice versa. Something from our present can affect the past, creating causal loops that are hidden from ordinary observation because they are outside linear time. Another category of hidden objects is virtual particles. Quantum mechanics states that even a completely empty vacuum is actually bubbling with activity. Particle and antiparticle pairs constantly arise out of nothing and disappear in a fraction of a second, so quickly that they cannot be directly observed. They exist in a quantum suspended state, hidden by Heisenberg's uncertainty principle. These virtual particles are not just a theoretical abstraction. They have real, measurable effects. The Casimir effect, for example, occurs due to virtual particles. If you place two metal plates very close together in a vacuum, there will be a weak force of attraction between them. This happens because only virtual particles with certain wavelengths can exist between the plates, while all possible ones exist outside. This imbalance creates pressure that pushes the plates towards each other. Near the event horizon of a black hole, virtual particles give rise to an even stranger effect: Hawking radiation. When a pair of virtual particles emerge right at the boundary of the event horizon, one of them can fall inside the black hole and the other escape to the outside. To an outside observer, it looks as if the black hole is radiating. This means that black holes are not completely black. They slowly evaporate, losing mass due to this quantum radiation. For large black holes, this process is incredibly slow. A supermassive black hole would take trillions of years to completely evaporate. But small primordial black holes, if they exist, could evaporate faster. When a black hole becomes very small, it evaporates faster and faster until it finally disappears in a burst of energy. These flares are hidden in space, and their detection would be proof of the existence of primordial black holes and confirmation of the Hawking theory. Quantum mechanics also assumes the existence of alternate realities. According to the many worlds interpretation of quantum mechanics, every time a quantum event occurs with multiple possible outcomes, the universe forks. All possible outcomes are realized, but in different parallel universes. This means that there are countless versions of you living in parallel realities where other decisions have been made, where history has taken a different path. These parallel universes are completely hidden from us. There is no connection between them, no way to communicate or travel from one to another. They exist in a quantum superspace of possibilities, forever separated from our branch of reality. If this interpretation is correct, then most of the reality is hidden from us simply because we are in one particular branch of the infinite quantum tree. But even in our own universe, there are areas where quantum mechanics and gravity meet in conditions so extreme that our theories break down. Inside the black hole, at the very core of the singularity, the density and curvature of space-time become infinite. Our equations no longer work. We don't know what's going on there. Some theorists suggest that the singularity may be a passage to another universe, or to another region of our own universe. It is possible that a new universe is born inside each black hole, which expands in its own space-time, completely separate from the parent universe. If this is the case, then our entire universe could exist inside the black hole of some larger universe, and we would never know about it. These ideas border on philosophy no less than with physics, but they show how deep stealth can be in space. Not just objects that are difficult to see due to distance or darkness, but entire levels of reality that can exist next to us but remain forever out of reach. Now let's get back to the more specific hidden objects. The Oort clouds are a hypothetical spherical shell of trillions of comets that surrounds a solar system at a distance of almost a light year from the Sun. It is the outermost part of our planetary system, and we have never observed it directly. We only know of its existence because some comets that approach the inner solar system have orbits that indicate their origin from this distant region. The Oort cloud is so distant that the objects in it are practically stationary. They drift in the dark, barely held back by the sun's weak gravity. From time to time, the passage of a nearby star or gravitational perturbations from the Milky Way give these objects a little push, and some of them begin a long journey into the inner system, turning into comets that we can observe. But what else could be lurking in the Oort cloud? Some astronomers suggest that there may be an undiscovered planet there, Planet 9 or Planet X. Circumstantial evidence, such as the unusual orbits of some trans-Neptunian objects, hints at the presence of a large planet somewhere on the outskirts of the solar system. If it exists, this planet could be 5 to 10 times more massive than Earth, but so distant and dim that we still haven't been able to find it. The search for this elusive planet continues. Astronomers systematically scan the sky, looking for faint light that moves against a background of fixed stars. But the search space is huge, and the object is dim. It's like looking for a needle in a haystack the size of the solar system. There is also the possibility that captured interstellar objects are lurking in the Oort cloud, matter from other star systems that was captured by the sun's gravity when our system passed through denser regions of the galaxy billions of years ago. These objects could carry information about other star systems, perhaps even organic molecules or traces of life from other worlds. Closer to us, in the asteroid belt between Mars and Jupiter, there are also hidden secrets. Most asteroids are small and inconspicuous, but some are strange. Ceres, the largest object in the asteroid belt, has bright spots on its surface that turn out to be salt deposits, possibly from a subsurface ocean. Liquid water can hide under the dark surface of Ceres, and where there is water, there could potentially be life. Other asteroids show signs of the presence of metals, organic molecules, even ice. Some of them may be fragments of planets that never formed, or the remnants of a planet that was destroyed billions of years ago. Each asteroid is a time capsule containing information about the early existence of the solar system, but most of them remain unexplored, hidden simply by their abundance and small size. There are also hidden objects of cosmic origin on Earth itself. Micrometeorites are constantly falling on our planet, tiny particles of cosmic dust that pass through the atmosphere and settle on the surface. Every day, about 100 tons of cosmic matter fall to Earth, but most of it is so small that it goes unnoticed. These particles may contain prebiotic molecules that help give birth to life on Earth, or even microscopic traces of extraterrestrial life. Some scientists are also looking for more exotic forms of cosmic matter on Earth. If dark matter is made up of heavy particles, then some of them can accumulate inside large objects such as Earth. Detectors deep underground look for signals from the annihilation of dark matter particles trapped in Earth's gravity. So far, the results are negative, but the search continues. There is also the phenomenon of transient phenomena, events that occur very quickly and then disappear. Fast radio flashes are powerful pulses of radio waves that last only milliseconds but emit as much energy as the sun does in a few days. They come from distant galaxies, and we still don't fully understand what causes them. Some fast radio flashes are repeated with a certain frequency. Others occur once and never again. This creates a mystery. Are there different sources there? The most popular theory links them to magnetars, but some flares are so strange and powerful that they force scientists to look for more exotic explanations. Every day, thousands of such flares occur in space, but most of them go unnoticed, hidden in the ocean of cosmic signals. What about gamma ray bursts? These are the most powerful explosions in the universe. In a few seconds, they emit more energy than the sun in their entire existence. They arise during the collapse of supermassive stars or the merger of neutron stars, and their radiation is so intense that if a gamma ray burst occurred in our galaxy a few thousand light years from Earth, it could destroy the ozone layer and cause a mass extinction. But here's what is stunning. These explosions are directed. They radiate most of their energy into narrow beams, like cosmic searchlights. This means that we only see gamma ray bursts that are randomly directed in our direction. How many of them are happening in directions that we cannot see? It is possible that every minute somewhere in the universe a massive star dies in a catastrophic explosion, but we don't know about it because its farewell beam flies the other way. There are also theoretical objects that have never been discovered, but can exist according to the laws of physics. Wormholes are hypothetical tunnels in space-time that connect two distant points in the universe. If they exist, traveling through a wormhole would allow you to travel vast distances in an instant, perhaps even to other galaxies or other eras of time. The problem is that wormholes are probably unstable. According to general relativity, they would collapse instantly if they were not kept open with exotic matter with negative energy. Such matter is possible quantum mechanically, but does it exist in sufficient quantities in the universe? We don't know. Perhaps highly advanced civilizations learned how to create and stabilize wormholes, using them as portals between the stars. If so, these portals could be scattered throughout the galaxy, completely hidden from us, until we reach a technological level enough to detect and exploit them. Another theoretical object is white holes. If a black hole is a region from which nothing can escape, then a white hole would be a region where nothing can enter. It would radiate matter and energy outwards. Mathematically, white holes are allowed by the equations of general relativity, but none have ever been discovered. Most physicists believe that they cannot exist in reality due to disturbances in thermodynamics and causality. But what if white holes existed in the early universe? They may have been sources of matter and energy in the first moments after the Big Bang and then disappeared. Or, an even more exotic possibility, a singularity inside a black hole could be connected to a white hole in another universe. Anything that falls into a black hole in our universe is ejected through a white hole somewhere else. If this is true, then black holes are not ultimate graves for matter, but portals through which matter is transported to other realities, forever hidden from our observation. Returning to our own era and place in the universe, it is worth mentioning cosmic mirages. Sometimes light from distant objects passes through regions with different densities of matter, intergalactic gas, plasma, magnetic fields, and is bent in unexpected ways. This can create phantom images of objects that are actually in a completely different location, or even hide real objects by deflecting their light. Astronomers try to account for these effects, but the cosmos is so large and complex that there is always the possibility that something is hidden from us simply because of the random configuration of matter between us and the object. Perhaps somewhere out there, there's a bright galaxy or quasar whose light is perfectly deflected from our view by a random cosmic mirage. There are also periodic phenomena that are hidden in time. Some objects are only active for short periods and then go silent for years, decades, or centuries. Cataclysmic variable stars flare up unpredictably. Repeated neoplasms explode every few years or decades. Unless we happen to observe these objects at the time of their activity, they remain hidden among billions of ordinary stars. The solar system also has its own hidden rhythms. Every 11 years, The sun's activity peaks when numerous spots, flares, and coronal mass ejections appear on its surface. Between peaks, the sun is relatively calm. But this is only the most obvious cycle. There are also longer cycles, centennial, millennial, that affect Earth's climate and space weather in ways we're just beginning to understand. And even deeper in time are hidden eras about which we know almost nothing. For the first 380,000 years after the Big Bang, the universe was opaque. The plasma was so hot and thick that light could not propagate freely. Everything that happened during this period is forever hidden from us behind an impenetrable fog of cosmic microwave background radiation. We can make theoretical assumptions, but we will never see this era directly. And what happened before the Big Bang? Was there anything at all? Some theories suggest a cyclical universe, where each Big Bang is followed by a Big Bang and then a new explosion. In such a scenario, there could have been previous universes before ours, each with its own history, its own stars, galaxies, perhaps even its own life forms. But all this information would be destroyed in the flames of collapse and rebirth, forever hidden from any possible observation. Other theories speak of the quantum origin of the universe, that it arose spontaneously from a quantum vacuum without any prior cause. In this case, the question of what was before simply does not make sense, since time itself only began to exist with the Big Bang. There is no before, no hidden backstory, only a quantum fluctuation that has blossomed into a whole universe. But perhaps the deepest secrecy in space is the secrecy of the future. We don't know what will happen to the universe in the long run. If dark energy continues to accelerate expansion, in 300 billion years, galaxies will be so far away that they will become invisible to each other. Each galaxy will find itself in an isolated island of space surrounded by empty darkness. In another trillion years, all stars will exhaust their fuel and go out. The universe will plunge into eternal darkness, illuminated only by the dim glow of evaporating black holes. And after countless eons, even black holes will completely evaporate, leaving only a rarefied sea of elementary particles drifting in infinitely expanding space. This is called the heat death of a universe, a state of maximum entropy where nothing else can happen, no structure, no life can arise. Or, if dark energy behaves differently than we think, another scenario is possible: the Big Rip. In this case, the accelerated expansion will become so intense that it will eventually tear apart not only galaxies, but also star systems, planets, molecules, atoms. The fabric of the space itself will be torn to pieces. This will happen in about 22 billion years, if this theory is correct. There's also the possibility of a big squeeze, if dark energy isn't enough. Or if it changes its nature, gravity could eventually win out and the universe will start to contract. All galaxies will begin to get closer to each other, temperatures will rise, and eventually the entire universe will collapse back into a singularity similar to the one from which it was born. Perhaps this will be immediately followed by a new Big Bang, and the cycle will begin again. Whatever future awaits our universe is hidden from us behind a veil of time and uncertainty. We can build models, make predictions, but we don't really know what will happen. And this is perhaps the deepest truth about the hidden objects of the cosmos. No matter how much we discover, there will always be more that is hidden from us. Every new telescope, every new detector, every new theory opens up regions of space that we didn't even know existed. 100 years ago, we did not know about the existence of other galaxies. 50 years ago, we didn't know about black holes and neutron stars as real objects. 20 years ago, we didn't know about dark energy. What will we discover next? Perhaps there are forms of matter and energy that our physics does not even suppose of. Perhaps there are dimensions of space that we cannot perceive. Perhaps there are civilizations so advanced that their technology seems to us like magic or natural phenomena. Perhaps our entire universe is just a small bubble in an endless multiverse foam, where each bubble is a separate universe with its own laws. The cosmos hides most of its secrets from us. Dark matter and dark energy make up 95% of the universe, and we don't know what they are. Black holes hide singularities where our laws of physics stop working. Quantum mechanics alludes to parallel realities that are forever separated from us. The enormous distances and limitations of the speed of light hide most galaxies from us. Time hides from us both the ancient past and the distant future. And yet, despite all this secrecy, we continue to search. We build more powerful telescopes, more sensitive detectors, develop more complex theories. Each generation of astronomers and physicists discovers something new, pushing the boundaries of the known a little further into the ocean of the unknown. And that's where the true beauty of space lies, not in what we know, but in what remains to be discovered. Hidden objects in space are not just astronomical curiosities. They remind us of our humility in the face of the greatness of the universe. They show us that reality is much richer and stranger than we could have imagined. They invite us to continue exploring, to keep asking questions, to keep looking up at the sky with wonder and curiosity. Perhaps the most important thing that hidden objects in the cosmos tell us is that the universe does not end with what we can see. Behind every curtain, behind every horizon, something new awaits. And as long as there is human curiosity, as long as there is our desire to know the unknown, we will continue to remove these veils, one by one, getting closer to understanding the true nature of the reality in which we live. The next time you look at the night sky, remember, what you see is just the thinnest slice of space. Behind the stars that shine in the dark, there's a whole universe of amazing, incredible, sometimes stunning objects and phenomena. We will never see most of them. Some of them we are just beginning to understand. And we don't even know about the existence of others. The universe keeps its secrets jealously, but it does not hide them with malice. Each mystery is an invitation, a challenge for the next generation of researchers. And who knows, maybe you will be the one who will discover the next hidden object of the cosmos, who will shed light on another cosmic mystery, who will take a step into the unknown and return with new knowledge about this amazing, endless, eternally hiding its wonders universe in which we are honored to exist.